Hello everyone, welcome back again with me. In this video, I want to show you about one of the matter in physics is about Wheatstone bridge. My name is Gusti Indra Prana with my student number is 2405531027. We got to the video. Number 1 is introduction. Introduction of the Wheatstone bridge is a classic electrical circuit used to measure unknown resistance with high accuracy. It was invented by Samuel Hunter Christie in 1833 and later popularized by Sir Charles Wheatstone in 1843. The bridge operates based on the principle of balancing two legs of a resistor network, allowing precise comparison between an unknown resistor and known standard resistors. A Wheatstone bridge typically consists of 4 resistors arranged in a diamond-shaped configuration, a voltage source, and a galvanometer for other sensitive voltmeter. Placed between the two midpoints, when the bridge is in a balanced condition, no current flows through the galvanometer, indicating that the ratio of resistance in one leg matches the ratio in other leg. The next is a basic concept of the Wheatstone bridge. Basic concept: the Wheatstone bridge is a highly effective and accurate electrical circuit used to measure unknown resistance by comparing it with known resistors. Its operation relies on the principle of balancing two voltage divider networks, where its zero reading on the galvanometer indicates that the bridge is in equilibrium. At these balanced conditions, the ratio of the resistance in one branch equals to ratio in the other, allowing the unknown resistance to be calculated precisely because of its simplicity, sensitivity, and reliability. The Wheatstone bridge remains a fundamental tool in electrical measurements. Laboratory experiments and sensor-based applications such as syringe gauge and temperature detection. The next, after the basic concept, is objective. Objective of the Wheatstone bridge is number 1 is to measure an unknown resistance accurately using the principle of bridge balancing. Number 2 is to understand the working principle of the Wheatstone bridge, including how voltage division leads to the balance condition. Number 3 is to analyze the relationship between known and unknown resistance using the balance equation. Number 4 is to learn how to adjust and balance the bridge using variable resistors or a sliding contact to achieve zero galvanometer deflection. And the next is to develop skill in using electrical measuring instruments such as galvanometers of voltmeter. The next is to observe the sensitivity of the bridge and now small change in resistance affect the balance condition. And the last one is to apply the Wheatstone bridge in practical measurements such as detecting small resistance change in sensor. And the next is Wheatstone bridge equation. That is 5 equations you can use in Wheatstone bridge. Number 1, the equation is 2 voltage divider equation in a Wheatstone bridge circuit. That is VB is the electrical potential at node B, and R1 and R2 from a voltage divider on the left sides of the Wheatstone bridge. And the fraction represents how much of the short voltage appear at node B. And VD, you can see on the equation number 1, is the electrical potential at node D. And R3 and R4 are the resistor in the right side voltage divider of the Wheatstone bridge. And number 2 is Wheatstone bridge balance conditions. The left side of the equation is the voltage ratio in the left leg of the bridge. The right side is the voltage ratio in the right leg of the bridge. When these two ratios are equal, the potential at nodes B and D are the same, so no current flows through the galvanometer. R1 and R2 resistor in the left branch, R3 and R4 resistor in the right branch. The numerator represents the resistor connect between the node of interest and the lower apply node. The denominator represents the total resistance in the branch. And equation number 3 is Wheatstone bridge balance ratio, or the balance bridge condition. The voltage at node B equals the voltage at node D. No current flows through the galvanometer. The bridge is in balance. The unknown resistor can be calculated accurately. R1, first resistor in the left branch. R2, second resistor in the left branch. R3, first resistor in the right branch. And R4, second resistor in the right branch. And number 4 is balance condition of a Wheatstone bridge circuit. R1 and R2 form one pair of resistor, and R3 and R4 form the other pair. And number 5, the fifth equation, this is for resistivity formula, or the resistance of a uniform conductor. And P, the resistivity of the material. L, the length of the conductor. A, the cross-sectional area of the conductor. And that's the equation you can use for Wheatstone bridge. And the next after equation is the step for determine the value of an unknown resistor. Number 1 is set up the circuit. You can use the connection box to place the unknown resistor in the setup serving as R1 and the unknown condition resistor serving as R2. Number 2 is connect the resistor to the output terminals to the power supply red and blue cables. And number 3, connect the midpoint between the two resistors to one input terminal of the ammeter. And number 4, connect the other input terminal of the ammeter G to the slider of the slide wire potentiometer. Number 5, adjust the slider. Number 6, record the slider positions on the ruler and determine L2. And number 7, repeat steps 1 until 6 for the other unknown resistor. And the last one is record all results in table. This is the table that what I talking about is labeling RX1, RX2, and RX2 again. And this is, you can see RC in ohm, L1 in millimeter, L2 in millimeter, Rx in ohm, actual Rx in ohm, and deviation in percent. The next after this table is step for determine electrical resistivity of Q&A. The number 1 is set up the circuit. As in experiment A, but replace the combination resistor RC with a resistor of approximately. And number 2, after confirming the circuit is correct, power the circuit using the power supply because the wire resistance is very small. Number 3 is adjust the slider until the bridge is balanced, indicated by zero current on the emitter. And number 4 is record the slider position L1 as well as L2. And the last one is repeat the measurement for the other wires. That's the step you can use for determine electrical resistivity of Q&A. And this is the table for resistivity, and this is diameter D in millimeter, L1 in millimeter, L2 in millimeter, R, and ohm A and millimeter square, and L per A is millimeter per millimeter square. This is in diameter is 1.0, 0.5, 0.35. That's it, the table of the resistivity and the reference you can use for Wheatstone bridge material of the physics. This is 2. One is investigatory project on Wheatstone bridge PDF, and number 2 is modul Praktikum Fisika Dasar Teknik Mesin Universitas Udayana 2025. This is the end of this video. Thank you for watching and see you again on the next video.